My name is Amit Sharma, working as an assistant professor in IIMT College of Engineering in the Department of Computer Science and Engineering. Now today we will discuss about the automata theory. This one is known as theory of automata and formal languages. The topic name is automata. Like this one is a black box. Or we can say that it is also known as finite automata, where we can give a set of sequence as an input. These are the input I1, input I2 and so on up to the n times, and produce a set of sequence as an output. These are O1, O2 and up to On. Now this automata is also known as finite automata. Now why we are saying that it is a finite automata? Reason, because we will give a set of sequence as an input. The input will be Q up to the number of finite set of states as an input symbols. That's why we are saying that this automata is also known as finite automata. Now next is types of finite automata. Basically, the finite automata will be categorized into two categories. First one is DFA and second one is NFA. DFA means deterministic finite automata that will be represented by a set of machine. This machine is also known as N. And the tuples, they can represent the machine. These are Q, sigma, del, Q naught and F. Now where M is the machine, Q is the non-empty finite set of states. Sigma is the non-empty finite set of input symbols. Del is the transition mapping. Q naught is the initial state. And F is the final state. Now, where the main difference between the NFA and DFA can play a major difference of transition mapping. This one is known as delta. The main difference for the NFA and DFA is transition mapping. For NFA, when we will take a set of symbol as an input symbol, we produce an output. The output will be in the form of the next state, like Q1, Q2, and A1. In NFA, when we will give a set of sequence or a set of symbol as an input symbol on a current state, there are maximum number of possibilities can be moved up to the multiple states. Q1, Q2 and so on. But in DFA, transition mapping will be defined when we will given a input on a current state, then we always get a single state. But in NFA, we will get multiple states as an output. These are the basic difference between the NFA and DFA. Now the representation of NFA and DFA will be categorized into two parts. First one is transition table. And second one is known as transition graph. This transition graph is also known as generalized transition graph. Now we can represent the transition table in the form of a tabular form, where it can be represented like this. These are the Q and this one is the sigma, where Q is the set of states like Q0, Q1 and so on, and sigma is the input symbols. If we represent, this one is known as arrow, this one is known as the starting symbol, means this state Q0 is the starting state. And then input symbols like 0, 1 and so on. Here we can get the next state when we will given a set of sequence, means the current state is Q0, we will given a particular input symbol on a Q0 state, then moves to the Q2, Q3 and anyone else. Same as it is further gone, we will design the particular transition table for a generalized transition graph. And for the final state we can represent the star like Qn. This one is known as the last state. Like transition graph. The transition graph will be represented by the form of the, this one is known as the state, transition state like Q0. Arrow represent the data flow. This state will be represented as the starting symbol. And the double circle is also known as last state. Now let us consider an example for designing. Design a DFA having even number of 0 and 1 over the input symbol 0, 1. Now we will design a particular finite state machine. There are multiple number of possibilities for even number of 0 and even number of 1, like first possibility 0, 0 2 times, or nothing, or 4 times, and so on. 1, 1 single times, multiple times, and so on. But there is a maximum number of possibilities through which we can get the combination of both 0 and 1, like 0, 0, 1, 1, 1, 1, 0, 0, 0, 1, 0, 1, 1 0 1 0 and so on. Now we will design a finite automata. Like we will start with the Q naught is the initial state. Now first condition, we will design for the even number of 0. Like even number of 0 0 0, and if the value will be 0, then this one is known as final state. Now move further for the 0 0 1 1. This one satisfied the second state. Now if we are going for the 0 1 0 1 and 1 1 0 1, then we will go through the now from this condition we can satisfy all of the condition through which we can get the even number of 0 and even number of 1s, like 0 1 0 1 0 1, and the state is closed. Like 0, from when we will given a particular Q naught, move to the Q1, then given a particular input on Q1, move to the Q3, then given a input 0, then we will move to the Q2, one given a input symbol Q1, move to the last state, this one is known as Q naught. So we will discuss in next class. The main topic is DFA.